Thank you. Thank you for that presentation and for inviting me to this meeting. I'm going to talk about two papers, mainly. Yeah, two papers and a bit more, but mainly two papers. One paper is on the climatic classification of the world's wine regions, and we published it in N01. The other one is on concentrations and similarities of wine grape varieties, and we published it in the American Journal of Enology and Viticulture. So I'm going to start with the first paper, the one on the climatic classification. What we did for this paper was to use data on 16 climate variables for basically all wine regions, more than 800. And we did principal component analysis, PCA, for data reduction, and then use the main components to cluster all these regions into three groups. And I will show you these three groups classification here in this slide. So we can see different bars in this globe. Each bar represents a region, and the height of each bar represents the vineyard area of each region. So longer bars, higher bars are related to regions with a higher vineyard area. And the color of each bar depends on the cluster of regions. So we have three clusters, three groups. The orange group is warm and also dry. There are high differences between day and night temperatures, high vapor pressure deficit, and high solar radiation. Then we have this green group that is also warm, but is wet. And because of that, it has low differences between day and night temperatures, medium levels of vapor pressure deficits, and solar radiations. And then we have one last group that is cool. This is the blue group, and it's mostly wet, with low differences between day and night temperatures, low vapor pressure deficits, and low solar radiations. Something interesting is that there's more or less an even number of regions in each of these groups, and that there are premium regions in each group, which shows that premium wine can be made over a wide range of climate types. We also look at this question: have the climates of these three groups already changed? For answering this question, we compare two 3-decade periods, a recent one with an older one. And what we can see is that growing season precipitation has decreased in the drier group and increased in the two wetter groups. And that all groups, all of them, the three of them, have become hotter, especially in the warmer months. And by the way, all these differences are statistically significant. I wanted to show you this graph. This is an interesting graph in which each bar, each gray bar, represents the ideal growing season temperature range for producing high-quality wine of each of these varieties. And I also plot three vertical lines that show the mean growing season temperature of each of the three groups. And I want you to look at the orange group and the green group. They have a mean growing season temperature that is higher than what is ideal for producing high-quality wine of these mainstream varieties, based on this graph. And now I'm going to show you the percentage of each of these varieties that falls within this ideal temperature range. These are the areas in parentheses. For some varieties, like Cabernet Sauvignon, it's quite high, but for others, like Zinfandel, it's quite low. And in total, 44% of the area planted to these varieties falls outside of these temperature ranges, mostly in regions that are too hot rather than too cold. And these varieties, these 21 varieties, account for half of the world's wine grape production. Something that I need to mention is that despite this is an interesting graph, it's also a contentious one, a controversial one, because there's research that shows that high-quality wine can be produced outside of these temperature ranges. And in fact, I remember that Greg Jones, who is the author of this graph, and is also one of the co-authors in our paper, added a sentence to our paper saying that our research shows that as well, that our research shows that high-quality wine can be produced outside of these temperature ranges. But still, I think it's a very useful graph for making the point that much of the world's wine grape production takes place in regions that are quite hot for producing high-quality wine of these varieties. And that, in the future, might become even more of an issue for two reasons. One is climate change, and the other one is that the demand for wine is shifting towards more premium products, towards higher quality wine. So that's the first paper. It's published in INO1. It's freely accessible, unlike the second one that I'm going to talk about. And something I want to mention is that there's a lot of interesting information in the supplementary data. For example, we are providing the mean growing season temperature, the area-weighted average mean growing season temperature for more than 1,700 varieties. Now I will talk about this second paper. What we did in this second paper was to use data on area by variety for basically all wine-producing countries, all of them. And we did some statistical analysis using two indexes that we computed using that data. One is a varietal concentration index, and the other one is a varietal similarity index. Now, here in this graph, we can see the top 20 countries by wine grape area based on their varietal similarities. And it looks complicated, but I will explain it. We can see that there's some horizontal lines. And those horizontal lines are united by vertical lines. The interpretation is that the longer these horizontal lines that are united, these countries or groups of countries, the less similar the mix of wine grape varieties between two countries or groups of countries. For example, if we look at the United States, we can see that it has a very similar mix of wine grape varieties to that of Chile or Australia. And to a lesser extent, it also has a similar mix of wine grape varieties to that of all these countries that include France, South Africa, and New Zealand. But its mix of wine grape varieties is quite different to the one of Argentina and all these European countries that we can see in the top part of the graph, namely Spain, Portugal, Greece, Germany, Hungary, Austria, and Italy. So this is based on our varietal concentration index. The other index is the varietal concentration index. And this index has a very straightforward interpretation. It answers this question. If two vineyard plots are randomly chosen in a country, what is the probability that they will have the same variety? For some countries, it's quite low, for other ones, it's quite high. Italy has the lowest varietal concentration index, 3%. The New Zealand has one of the highest, 37%, mainly because it's so concentrated in Sauvignon Blanc. And the US is somewhere in between these two, with 9%, which is a pretty standard value for most non-European wine-producing countries. So the answer to this question for the US is 9%. Now here, I'm showing both indexes. So we can see the varietal concentration index in the horizontal axis and the varietal similarity index in the vertical axis. And there are three groups of countries. The most important group of countries is this of yellow circles, and that is because four-fifths of the world's wine grape area is planted to those countries. These are countries that are quite similar to the world as a whole in their mix of wine grape varieties, but are not super concentrated. And I'm sorry, there's supposed to be some flags, but now they transform themselves into letters. But the US is in this country, is in this group, and also France, Spain, Italy, Chile.
South Africa?
No. Yeah, South Africa and Australia. It's easier with the flags. Then we have a group of countries denoted by squares that are not that similar to the world as a whole in the varietal mix and are not super concentrated. And Argentina, Portugal, and Germany are probably the best examples. And then we have this last group of countries denoted by triangles, which are not that similar to the world and are super concentrated. The best examples are probably New Zealand and Georgia. We also use our indexes for answering this question. are countries becoming more or less similar in their varietal mixes and more or less concentrated. And what we can see based on our indexes is that the varietal mixes are becoming more similar across countries and with respect to the world, and more concentrated within countries and globally. So countries are becoming more similar between them and with respect to the world, and they're also becoming more concentrated. And I want to show you this graph. This graph shows the share of the world's wine grape area for the top 15 varieties as for 2016, and how that area share changed between 2000 and 2016. So these 15 varieties account for half of the world's wine grape area. There are more than 1,700 varieties in our database, but these 15 varieties account for half of the world's wine grape area. There are two Italian varieties, Trebbiano Toscano, which surface decreased a little bit, and Sangiovese, which surface increased during this period. There's one German variety, Riesling, which surface increased quite considerably. 4 Spanish varieties, the surface of Tempranillo has increased tremendously, but the surface of Irene, Grenache, and Boval, the other 3, has decreased quite a lot. In fact, Irene was the most planted variety at the beginning of the century, but not anymore. Now the most planted variety is Cabernet Sauvignon, which is French. And I want you to look at all the French varieties, which again would be easier with the flags. But look at Cabernet Sauvignon, Merlot, Chardonnay, Shiraz, Sauvignon Blanc, Pinot Noir, Cabernet Franc, and Malbec. The surface of all these varieties has increased quite a lot during this period. And that is something that we have seen in the past few decades. There's a trend, a shift towards French varieties, some key French varieties. And I will show you a good example of this. This is an example for Australia. Here we can see the Australian share of area by the variety's country of origin. In the 1950s, early 60s, the share planted to Spanish varieties was more than 40%. And that was a time when the French share was less than the Greek share, less than 20%, with Turkey next at about 10%. But the surface of some grape varieties like Grenache from Spain and Sultana from Turkey has decreased tremendously. And at the same time, the surface of some key French varieties from France has increased so much that now about 90% of the Australian vineyard area is planted to French varieties. Now, does this increase in concentration translate into less diversity for consumers? The answer is no, and that's because these changes in concentration have been lower than the massive changes in the massive increases in wine trade that we have seen over the past few decades. 2 of every 5 bottles of wine that are consumed globally are imported, actually more than that. That said, other research that we have done shows that countries with a more similar mix of wine grape varieties tend to trade more wine between them. Another interesting question, especially in the context of climate change, is whether countries with more similar climates are becoming more similar in their varietal mixes. And the answer is yes, and this might seem like a good thing, but our research shows that these countries might not necessarily be evolving towards varieties that might be ideal for their climates. Overall, it looks like wine growers have found it more profitable to focus on some key mainstream varieties. And that leads us to policy-relevant questions like this one. How much of this concentration is caused by European countries with strict planting regulations? And the answer is not a lot. There does not seem to be an association between how concentrated countries are and the right that growers have of choosing the wine grape varieties, or even in having the right to plant. And what that might suggest, perhaps, is that focusing on marketing by geographical indications, like many European countries do, instead of marketing by variety, like most non-European countries do, might help increase the share of these varieties that might be more appropriate for the climates of the regions of the different countries. So what other policies could help increase the share of less planted varieties that have good potential? There might likely be many. One is for industry bodies to invest in the promotion of these lesser-known varieties, and others involve changes in regulations. Just a heads up, all this data that we have used for these papers and for this presentation are available for free from the website of the Wine Economics Research Center of the University of Adelaide. It's free. You can download this data as Excel files. There are also working papers and wine briefs that might be of interest. So that's my presentation, but I want to thank IVES again for inviting me here, which has been good for a wide variety of reasons, not only for coming to California, which is a great state, but also because I have been able to talk to the industry, which is something that we do quite a lot in Australia, but not that much with other countries. And it's great to talk with people in California because we are going to do some research at the center that relates to California. We are planning on producing a database for California that is very similar to one that we produce for Australia with many, many indicators and time series and concordances and so on. We will produce about sometime between 100 and 200 different tables with indicators. And we are also planning on doing some research here, or at least some research collaborations. And before coming here, I went 3 days to UC Davis, and we are going to collaborate to a certain extent in some climate change impact models and also on some supply response models. And I have also been talking with people that have come here to this conference because this global database that I have introduced is updated until 2016. That's the most recent year. But this year, we're going to update it until 2023. And something that we want is to work with people that are producing other types of databases in other countries, but that could be used with this one. So we want to get a concordance between all these databases. So that's something great that has been a consequence of coming here. Thank you.